Hello everyone, this is Dr. K. Evangeline Supriya working as an associate professor in the Department of Humanities and Science, SRIT Engineering College, Anantapur, Andhra Pradesh. Today we are going to perform the dark room experiments, out of which we are going to study the formation of thickness of the thin wire by using the wedge method. So looking at the apparatus, this is the sodium vapor lamp, which is a monochromatic source. This is the traveling microscope. This entire apparatus is a traveling microscope. Here we are having the telescope. Here we are having the two glass plates, and then we are having the one glass plate which is inclined at 45 degrees. Now, in order to find out the thickness of the given thin wire, we are having here thin wire. You can take any thin object. As you can see this, these are the two glass plates. How the wedge arrangement means, a wedge arrangement is an arrangement which will consist of two identical glass plates which are having the point of contact at one end, and the object whose thickness is to be found is placed at the another end of the glass plates. Now this arrangement has to be placed on the carbon paper which is arranged below the telescope on the wood, and the glass plate which is inclined at an angle of 45 degrees. Now when a monochromatic light source is incident on the glass plate at an angle of 45 degrees, now the light will reflect on the air film which is formed between the two identical glass plates. Now the light will reflect from the lower surface and the upper surface and lower surface of the air film, and will superimpose and forms a interference pattern which are having the alternative dark and bright fringes. These alternative dark and bright fringes. Now, in order to find out this thickness of a thin wire, we have to place the cross wire on the 10th ring. As you can see this, here we are having the alternative. We can view the formation of alternative dark and bright fringes by using the telescope. As you can see clearly, the formation of dark and bright parallel fringes. Now these are the keys to move the telescope and to adjust the fringes. As you can see, I have focused uh, on the 20th ring. As you can see, these are the formation of dark fringes, parallel fringes. Now we can see the we have to focus on consider a ring and focus the cross wire like this. Consider it as 0, and then 1, 2, 3, 4, 5, 6, up to you go up to 25. Consider this is the 25th ring. Now from 0 you coincidence the cross wire and take the main scale reading and vernier scale reading. So what is the least count? The minimum value with which any device can get, the least value any device can get is nothing but least count. As you can see here, the least count of the traveling microscope is value of one main scale division by total number of vernier scale divisions. As you can see this in the traveling microscope, there are two scales. One is horizontal scale and another one is vertical scale. Both horizontal scale and vertical scale have two vernier scales. Here it is having one vernier scale and the horizontal scale is having the one vernier scale. But the arrangement we have kept is completely horizontal. So we are taking the readings from the horizontal scale only. So as you can see this, the number of vernier scale divisions here are 50 vernier scale divisions. So the total number of vernier scale divisions are 50 divisions, and the value of one main scale division is 0.05 centimeters. So the least count of the traveling microscope is 0.001 centimeters, and the wavelength of the given sodium vapor lamp is 5893 into 10 to the power of minus 8 centimeters. Now to determine the thickness of the thin wire, as I already said, I have coincidence the cross wire. Say it is as 0th ring, and I have taken the both main scale reading and vernier scale reading. Here, out of the 50 divisions, one of the division will coincidence with the main scale, that will be considered as a vernier scale reading. So the vernier scale reading must be between 0 and 50. And how can we measure the main scale reading? Means the 0th scale, the 0th line of the vernier scale division coincidence with the main scale division. As you can see here, it is having the 9.8. It is having the 9.8. Now likewise, you have to move the traveling microscope with the screw from 0 to 5, 5 to 20, 5 to 10, 10 to 15, 5 consecutive rings. I am moving the taking the reading through the telescope from 0 to 5, 5 to 10, 10 to 15, 15 to 20, to 20 to 25. Likewise, for 0th ring, 5th ring, 10th ring, 15th ring, 20 ring and 25th ring, we have to take the readings. After taking all the readings, we have to measure the width of the 5 fringes in centimeters, and then we have to measure the fringe width in centimeters. Now after determining all these things, we have to take the average of the fringe width, and that should be substituted in the formula. Here, thickness of the given material T is given by lambda T by 2 beta, where lambda is the wavelength of the sodium light. As I already told, it is 5893 into 10 to the power of minus 8. D is, we will get the distance between the point of contact and the glass plate, and 2, and then beta is the value, that is the fringe width we will get from the fringe width table. So after calculating all the values, we will get the thickness of the given material by using the wedge method. Thus, that is how we can determine the thickness of the any thin wire by using the wedge arrangement, which consists of 2 identical glass plates having a point of contact at one end, and the object whose thickness is to be found is placed at another end. The principle involved in this experiment is interference, change in intensity at the point of superposition. As you can see, over here there are formation of parallel dark and bright fringes. So here we have considered the dark fringes. We can see the glass plate inclined at 45 degrees, and the 2 identical glass plates we have considered as L1 and L2. The air wedge is considered as W, and the sodium vapor lamp. And then we can see how the rays is incident on the glass plate and how they reflected. That's how the interference will happen, and it leads to the formation of parallel dark and bright fringes. That is how we can determine the thickness of the thin wire by using this air wedge method. Thank you.